In this video, we are going to talk about solving trig equations. So our goal is to get the trig function alone. So in this number 1, I'm going to minus 1 and then divide by 2. And so I'm going to get cosine of theta equals negative 1/2. Now, I want to think about where my cosine is negative 1/2. Well, cosine is negative in quadrants 2, so that'd be at 2 pi over 3. And in quadrant 3, which would be 4 pi over 3. Now in the directions, it says find the general solution, meaning that we are going to write an equation to represent all the solutions using plus 2k pi, where k is any integer. So when I write the solution, I'm going to write 2 pi over 3 plus 2 pi k and 4 pi over 3 plus 2 pi k. And so this would be my general solution for number 1. In number 2, I'm going to get this cotangent alone by subtracting 1. So I'm going to get cotangent of theta as negative 1. Now cotangent is negative 1 at 3 pi over 4 and at 7 pi over 4. Now with tangent and cotangent, when we write our general solution, we're going to write it as plus pi k, because if you notice 3 pi over 4 and 7 pi over 4 are pi apart. So I can just write my formula as 3 pi over 4 plus pi k. I don't even need this second equation. Now you could write it as 3 pi over 4 plus 2 pi k and 7 pi over 4 plus 2 pi k, but this is a little bit more of a concise answer. In these next examples, it says find all the solutions on the interval of 0 to 2 pi. So we're going to find our solutions in radians on the unit circle. So if I'm going to solve number 3, I'm going to divide by 4. And then I don't want the sign squared. I want the sign. So I'm going to take the square root of both sides. Remember, when you take the square root, you're going to get plus or minus. I'm going to get root 3 over 2 because the square root of 4 is 2. So I want to think about all the places where a sign is positive or negative root 3 over 2. So that'll be at pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. In number 4, again, I want to solve for the secant, so I'm going to add 4. Take the square root of both sides, and I'm going to have the secant equals plus or minus 2. So again, secant is the reciprocal of cosine, so it's really when their cosine equals positive or negative 1/2. So on the unit circle, that's going to be at pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. All right, in this next section, it says pay attention to the indicated domain. So in this first example, we're still solving from 0 to 2 pi. So if I look at this, I have 2 cosine squared plus cosine. So I'm going to factor out a GCF of cosine, so I'll be left with 2 cosine plus 1. Now once it's factored, we can set each of our factors equal to 0 and solve. So cosine b equals 0. So where is cosine 0? Cosine is 0 at pi over 2 and at 3 pi over 2. If I solve for cosine here, I'm going to get that cosine is negative 1/2, and that happens at 2 pi over 3 and at 4 pi over 3. And so those would be my 4 solutions. Here I'm solving from negative 90 to 90, so I'll keep that in mind when I get to the solving part. But right now I have a trinomial. So this is the same as if I had 2x squared minus x minus 1. So I need to factor it. So my first terms are going to be 2x and x. And then it needs to multiply to negative 1, but add to negative 1. So I'm going to have negative 1 plus 1, because this would be 1 minus 2 would give me negative 1. So I'm going to have 2 sine x plus 1 equals 0 and sine x minus 1 equals 0. So sine of x would equal negative 1/2, and sine of x would equal 1. So I need to think about the interval of negative 90 to 90, so in degrees, where my sine is negative 1/2. Well, my sine is negative 1/2 at 330 degrees and at 240 degrees. But I'm thinking between negative 90 and 90. So this would be negative 30 degrees. And then this would be negative 150 degrees, but that's not within my interval, so I can't include that. Where is sine 1? Well, sine is 1 at 90 degrees, and so that'd be my solution for that. So my two solutions would be negative 30 and 90. In number 7, we are solving this for all reals, but again, I need my equation to be equal to 0 before I can factor this. And I can see once I move the cosine over, I'm going to have a GCF of cosine. So I'm going to factor out a cosine. I'm left with tangent of x minus 1 equals 0. So I'm going to have cosine equals 0 and tangent of x minus 1 equals 0. So tangent of x would equal 1. So I need to find the places where cosine is 0 and where tangent is 1. And again, I'm writing my general formula. So it'll be plus 2 pi k for cosine and plus pi k for tangent. So cosine is 0 at pi over 2 but the problem is tangent is undefined at pi over 2, 3 pi over 2, 5 pi over 2. So this solution actually won't work because the tangent's undefined there. So my only solutions are going to come from the tangent of 1, which is pi over 4 plus pi k. Now, tangent's also 1 at 5 pi over 4, but again, 5 pi over 4 is pi away from pi over 4, so I don't need that second equation in this situation. So this would be my only solution. In number 8, I have two different trig functions. I need to change this so it's all the same trig function. So I'm going to use one of my cosine of double angle formulas. So one of those has to do with sine. It's 1 minus 2 sine squared minus sine. Now I can see I have a sine squared, which means that this is a quadratic, so I know I need equal to 0. So I'll end up with negative 2 sine squared minus sine equals 0. So I'm going to factor out a negative sign, so I'm left with 2 sine plus 1. And then set each of my factors equal to 0. So sine of x equals 0, and sine of x would equal negative 1/2. So sine is 0 at, well, I'm looking between 0 and 360. So 0 degrees and 180 degrees. Sine is negative 1/2 at 210 degrees and at 330 degrees. And so those would be my 4 solutions. All right, number 9, we're solving on this idea of all reals. So that'd be plus 2 pi k, because we just have sine and cosine. But again, I have two different trig functions. So usually I'm going to look to change the one with the squared because I can use my Pythagorean identities. So I know sine squared plus cosine squared is 1. So I know that cosine squared is the same as 1 minus sine squared. And this will give me all the same trig functions, so that way I can solve this. So I'm going to have 1 plus sine equals 2 minus 2 sine squared. Now this is a quadratic equation, so I need it equal to 0. So you could either move the left side to the right or the right side to the left. I'm going to move the left side to the right because I want a positive sine squared. So I'm going to have 2 sine squared plus sine, and then 2 minus 1 is minus 1. So this is really 2, let's call it b squared plus b minus 1. So this will factor into 2b and b. And it's got to multiply to negative 1 but add to 1. So positive 1, negative 1. So I'm going to end up with 2 sine minus 1 and sine plus 1. So sine is 1/2 and sine is negative 1. So again, I'm writing my general formula. So sine is 1/2 at pi over 6 and 5 pi over 6. Sine is negative 1 at 3 pi over 2. So these would be my equations. All right, in number 10, I don't have anything that's squared like I did in number 9. So I can't substitute any of my Pythagorean identities. But I can if I square both sides. Now, this is mathematically legal, but we have to be careful because squaring leads to extraneous solutions. So what that means is now that we squared both sides, I'm going to have to check my answers to make sure they actually all work. So sine of x plus 1 times sine of x plus 1 would give me sine squared plus 2 sine plus 1 is equal to cosine squared. Now I want all the same trig functions, so since I have mostly sines on the left, I'm going to change cosine squared to 1 minus sine squared. Then I'm going to move those to the other side, so I'll end up with 2 sine squared plus 2 sine, and when you minus the 1, you get 0. So then I can factor out a GCF of 2 sine, and that'll leave me with sine plus 1. So I'll have 2 sine x equals 0, which means sine of x equals 0. And I'll have sine of x plus 1 equals 0. So sine of x equals negative 1. So now I'm solving between 0 and 2 pi. So sine is 0 at 0 and pi. Sine is negative 1 at 3 pi over 2. Now we have to check these really quick. So I'm going to have sine of 0 plus 1 would equal cosine of 0. Well, sine at 0 is 0. 0 plus 1 is 1. Cosine at 0 is 1, so that's true. Sine of pi plus 1 should be equal to cosine of pi. Well, sine at pi is 0. So 0 plus 1 is 1. Cosine at pi is negative 1, so this is not going to work. Sine of 3 pi over 2 plus 1 should be equal to the cosine at 3 pi over 2. Sine at 3 pi over 2 is negative 1. Negative 1 plus 1 is 0, which is what the cosine at 3 pi over 2 is. So my two solutions are 0 and 3 pi over 2. In this last example, again, I have different trig functions, so I'm going to change this tangent squared to secant squared minus 1. So I'm going to put 2 secant squared minus 2 plus 3 secant. So I'm going to do some rearranging because this is a trinomial. And so I'm going to think about this as 2x squared plus 3x minus 2. So that'll factor 2x and x, and then I need a negative 2 but a positive 3. So if I do plus 2, that gives me 4. Minus 1 would give me 3. So I'm going to end up with 2 secant minus 1 equals 0. Secant plus 2 equals 0. So secant of x equals 1/2. And secant of x equals negative 2. Now, we could think of this, but I like to always change it into cosines. Just be cosine of x equals 2. And cosine of x equals negative 1/2. Now, cosine does not equal 2 ever on the unit circle, so this part is a no solution. But on this part, I will get, where am I finding? All reals. So cosine is negative 1/2 at 2 pi over 3 and 4 pi over 3. And so those would be my solutions to this problem.